Okay, before we get started, I wanted to kind of just check and gauge how you guys are doing. So you can tell me. I've been kind of monitoring the activity on Piazza, and wanted to maybe just I don't know, address any kind of concerns and just to say a few things about homework and school and life and a few things. So okay, well, first off, maybe this will help. I don't know. Would it be useful to have a 24-hour extension for the homework? Yes. Okay, so I will grant you guys an additional. All right, so I'll change the homework due date. I'll give you guys an extra 24 hours, but hold on. I do want to say this also. Okay, I do want to say this. You know, I'm thankful that you guys are working hard and working hard on the homework, and I truly appreciate that. I also want to make it okay to do bad on a homework. All right, you don't have to feel bad if you can't get your tic-tac-toe program working. All right, I purposely did not make, for this instance, I did not make tic-tac-toe worth the entire homework assignment. And the most difficult portion being the computer turn function, that's only worth 10 points. And so if you get everything else working and you can't get computer turn working, and you're sick of this thing, just call it a day and say, all right, I'll accept my loss for not getting computer turn working and turn in what you have. If you have a 2-player game working where it can see if somebody wins and whatnot, you'll get most of your credit for that. And I want you to feel okay. I know you guys are UCLA students, meaning you were all at the top of your, in high school you were number 1, number 2, and you always turned in all of your homework, you didn't slack off, and that was life. I mean, I get it, I was there also, but you know, there's the assignments, the classes, they're more challenging here, and it's okay, all right? It's okay. I want you guys not to feel guilty or shame if you couldn't get it working. You did your best, turn in what you have, and whatnot. Okay, I'll give you guys an extra 24 hours. That might, make you relax a little bit, but it's okay, all right? You'll be graded on what you turn in. If you can't get computer turn working, it's fine. And just in general, your academic performance here at school, whether it's on tests or homework, these are not measures of you as a person. Okay, it feels good to get A's, it feels good to get good grades, okay, but they are not who you are as a person, okay? So anyway, I just want to say that, all right? So I don't want anybody to get too stressed out or angry about the homework assignment. I also want to say a few things about the use of NA in these vectors, okay? It seems like a lot of people are maybe frustrated by my choice of representing unplayed spaces by NAs. And I want to kind of at least offer a defense of that choice. And I also want to say, if you want to just turn all of the NAs into character numbers, that's fine, okay? But R is, from the very start, the programming language R had an NA built in to represent missing values, which is, unique, or fairly unique among many programming languages. Many other programming languages, you cannot say, here's a value that has no value, right? Here's a value that is missing. And I'm of the persuasion that if you don't know the value, it should be represented with an NA rather than a different character, okay? And there are tools such as is.na in the R language to check for things. So if you can always feed into your state. Let's say state is you're repeating a bunch of NAs 9 times or something like that. You can always do is.na state, all right, and it will return true for all the things that are missing. Okay, and this way you can kind of, for I in 1 through 9, you can do is.na on here, okay? And you can just say you can do something like this. If it's NA, print out I, otherwise print out state sub I, right? And this is just for, you're going to cat this along with space, right? And so you can easily do things like this, and if you update the state so that in position 5 you have an X, and in position 6 you have an O, and you run through things like this, you can easily print out the characters so that it's not too difficult to go through in terms of printing out the things you need, right? And you can, if you want to do something like this, you have this, and then oops, what else do I want to do? And then you say I don't know, whatever, okay. But I'm sure you guys have figured out your display function by now. But maybe it's too late. You've already replaced all the NAs with characters, and that's fine. But I do like the use of NAs in general for things. And this just allows, later on, you can just do sum of basically state equal to X, right? Any.rm equals true. Okay, and you can check things this way. I guess you could have done this if you have character vectors, but I don't know. Whatever else. So there are tools in R to handle the NAs. Okay. Are there any questions regarding this? Yes.
Do all the test cases have to work?
So, okay, yeah, one thing about the test cases, yes, you want your test cases to work. If the way you've written your code is not compatible with the way I've written my test case, then you can modify the test case, okay? As long as you maintain the spirit of the test case, I'm okay with you modifying a few things in the test case, all right? So if the test case is trying to see if if it will detect if X has 1 in a certain case, then the display of the board should remain the same, and the output should be of that nature. Okay. Are there other questions? Yes.
So the computer doesn't have to be very smart.
The computer does not have to be smart at all. Okay. It can play terrible. And that's fine, all right? The point was, can you get... We're not trying to program an AI that's unbeatable, all right? Yes, there are ways to make it so, okay, for tic-tac-toe, but it was just, can you implement the rules of tic-tac-toe, right? Like, can you put in an X, and if you get 3 X's in a row, will the game say somebody wins? That's all we wanted. And as far as computer turn goes, it can just play in random spots, right? For the computer turn to be, quote, correct, it needs to win where it can win and block where it can block. But as far as like looking ahead to seeing like whether it should play in the corner or the side, that part doesn't matter to me. Okay? Yes?
So if the spy is taken, do I consider like end the game where another one?
I don't understand your...
So like, there's one on the update function.
Yeah.
If the spy is already taken, should I like call again and put another
So
password O or?
it should tell you that you are not allowed to play in that position. Okay. How you decide to handle that is I'll leave up to you. Okay. We'll end there, and for regarding the tic-tac-toe and the homework and all of that, and just again, do your best. That's all I can ask for. The extra, the extra points are not worth copying someone else's code. All right, you want to be able to submit something and be proud of what you submitted, and if you resort to copying someone else's thing, I think you lose a lot of that sense of doing. I don't know what I'm trying to say. I guess when you work hard and it produces something, you get a sense of accomplishment. You get a sense of purpose in kind of your labors. And if you just end up copying someone else's thing, then there was your labors are not being put on display. And I strongly discourage that. I know it can be tempting, but resist that temptation and turn in what you have, doing the best that you can. So, all right, today we're going to talk about getting data into R, and we're going to look at this package rvest, which I think is pretty cool. And so we'll do this, okay? So as far as getting data into R, there is a few commands. Read.csv is probably one that you guys are familiar with. That's for reading in CSV files. You have read.table, and then you have readline and scanline, and those are even like, so scan will like just read in the file. Readline will get input from the terminal, and that's probably how you're prompting users for input in your tic-tac-toe function, things like that. You got a table of stuff or a file, you can read those in. If you have big files, then I strongly encourage trying out some of these other packages, such as readr. Okay, so read_CSV is much faster than regular old read.csv. So you can just load up that package and use read_CSV. And the advantage of read_CSV is not just the speed. The speed is a great thing, but it also does not default to strings as factors, okay, which read.csv does, and things of that nature. You got Excel files or other files from other things. There's these packages here as well. And then if you have really large tables, on the order of hundreds of thousands of rows, or then data.table can be a good package to have. Okay, and all of these things you can read about them. There is package downloader. Okay, so a lot of times there might be some web address where there's a CSV file. Okay, you can read those files in directly into R. You don't even have to download it and then tell R to load the package from your hard drive. You can just say load the package and you provide it the URL. Okay. However, the download and that function will not work if you have an HTTPS connection, which is getting more and more common. Now I feel like 90% of my web addresses are HTTPS, okay? And I think that's a good thing, And so library downloader helps allows us to connect over HTTPS. Okay, there's other packages like curl and stuff, but they're more complicated. Okay, library downloader usually does the trick for secure connections. All right. We also have a package lubridate, which handles date and time information in R. So date and time information prior to lubridate was like super tedious and frustrating. And so I'm just to show you how much better lubridate is, I'm going to show you these examples of how importing date had to be done without package lubridate. Okay, so let's say you have character strings like 6 August 2005. I don't know if you guys can see this. And if you wanted, or January 15, 1999, or 12/15/2001, if you wanted to read this in without lubridate, you would say, I want to do as.date, you provide it the string, and then you have to provide the formatting, okay? And you have to use % lowercase d, %capital B, %capital Y, and the as.date function, I think, does it have? I don't know. Where is the format? Okay. All right. I don't even remember where the formats are, but these formats had to be typed out exactly. And if you used a capital D rather than a lowercase d, or a lowercase b rather than a capital B, or if you did an M instead of a B. So here, for the word August, we would have to write %B, or the word January, we had to write %capital B there. Whereas if you wanted the month in using a number 12 for December, you had to write %M. And if you got any of these things mixed up, or if you didn't put the space or the comma or anything, the importing date would fail, okay? And if you had people, if one person wrote January 15, 1999, and then somebody else in the same text field wrote this, then it would fail, okay? And so importing dates was always super painful, okay? With lubridate, it's very easy. Yeah, I guess all you have to do is just do lubridate, and then you just say, here is some date, okay, and it's in the form day, month, year. All you have to do is kind of specify day, month, year, and then it will convert it into a date. This is the output of this is going to be a date class object. Okay. Interestingly enough, the type of on a date is just a number. Okay. And if we did as.double, it says 13,001. Okay, 13,001. This is just the number of days since, I want to say January 1st, 1970 or something like that. Okay, we just picked an arbitrary date and point in time, and we said this is the 0, and everything after that is just a 1. Okay, it's actually not too different than our modern date system that we have today. There is an arbitrary point in time, okay, based, religious significance, and then today's date is really just a certain number of days, except to make the number, quote, more digestible, we divide it by 365 and a quarter, and we say this, and we have all these like weird rules about how to keep track of the dates today, right? Like every 4th year we add an extra day in the month of February, which is oddly 28 days versus, our calendar system today is really weird. It's probably a lot easier to just say, oh, it's been 13,000 days. But anyway, to go with and all you have to do is you just say, whoops. you say day, month, day, year, or month, day, year, and it handles these things with no problem, okay? And it turns these into date things. So lubridate, anytime, if you're ever going to deal with some date information, I strongly recommend using lubridate, okay? And okay, and then now I'm going to talk about rvest. Rvest is for web scraping, okay? Kind of play on the word for harvesting data, and we use rvest in conjunction with something known as the selector gadget, okay? And so I'll go to that web page for selector gadget, and then we'll use the pipe in a second here. But here is the selector gadget, and to use the selector gadget, all you have to do is it says drag this link to your bookmark bar, selector gadget. Okay, so you just take this and you drag it up to your bookmarks bar, all right? And so all it is a little script, and then when you click it, some stuff happens, okay? And I'll demonstrate how this works. So before we get into using the selector gadget and using rvest, I want to talk a little bit about piping. Have you guys seen piping before? Okay, so some of you, yes, some of you know. The pipe operator takes the result of one function and feeds it in as the first argument of the next function, okay? And so sometimes you want to do a bunch of stuff like take all the integers. So let's say you want to do this thing, all the integers from 1 through 1,000, find the ones that are divisible by 3, find the ones that are less than 200, or the ones that are greater than 800, and then take the square root of kind of those remaining values, okay? If you didn't have you didn't do piping, you would have to do some kind of crazy subsetting operation, and you'd say subset the values 1 through 1,000 that are divisible by 3, and then further subset that, and it gets really kind of messy, right? One way to kind of avoid the messiness is to say, first we're going to take A and set it equal to 1 through 1,000. And then if I want those divisible by 3, I would say A divisible by 3 and subset that and take that output and store that as B. And then if I want to take those that are less than 200 and greater than 800, I would say, okay, subset B by finding those that are less than 200 and greater than 800, store that into C, and to say I want the standard deviation of that resulting thing, okay? So this, I think this makes sense by taking kind of breaking up your task and saying, take the output and store it here, and then we're going to take that thing that we stored and put it into the next function. What piping does is it basically allows us to do this series of operations without having to store them into A and then into B and then into C. It just says, take this output, run it into this thing, then take that output, run it into the next function, and take that output and run it into the last function, okay? Whereas if you didn't set it aside this way, you would have to nest the functions, and whenever you nest the functions, the arguments that modify the thing that you're dealing with get further and further away from whatever it is that you're trying to do. And so here, what is the innermost subset? It's actually, it's this one, or I'm not sure. Now I can't even tell anymore. But nesting functions can often get quite messy. So using intermediate values in between is often helpful, and piping just allows us to kind of skip the intermediate values while maintaining this logical step-by-step procedure. So with piping, we just say take the values 1 through 1,000, okay? Pipe that into the subset operator, okay? And then the dot means take the previous value and stick it in here. So subset those to find those that are divisible by 3. and then take that result, subset it into, further subset it, taking those that are less than 200 or greater than 800, and take that result and pipe that into the standard deviation function. Okay? So piping maintains kind of this step-by-step procedure without having to store them into A, B, C, and D. And it just allows you to go through it. And so we will use this kind of series of functions when we use rvest, because a lot of times we will take, when we're dealing with a page, we're going to say take the contents of the page and then apply a function to that contents, and then take that result and then apply another function to that result. And it's just a lot easier when you're dealing with pipes rather than having to nest functions inside each other or having to store each of these values somewhere else. Okay, so let's do this rvest demo here. I believe I've uploaded this into the week 4 section. You can download this R code for rvest demo. You're going to need to install the package rvest and a couple other packages. Stringer allows us to handle strings, maybe a data table for the very last operation. Okay, and the very first thing we're going to do is we're going to go to what we're going to do is we're going to scrape information off of this IMDb webpage for the Lego movie, okay, which is now 4 years old, but I just got I'm a fan of the Lego movie and the Lego Batman movie. I've not seen the Lego Ninjago movie, but I don't know. All right, anyway, so let's say we want to extract information from this web page, right? And so I don't know how familiar you guys are with kind of web technologies, but on any web page, you can always kind of go to the menu in the corner and look, go to Tools and, where is it? Okay, well, I don't know where it is. You just right-click the page and you can click View Page Source, okay? And when you click View Page Source, you see all of this gibberish, okay? But it's, well, some of it is JavaScript, okay? But a lot of it is going to be HTML. That's kind of the standard way of displaying websites. And so, you know, maybe you've learned about HTML, maybe not. But everything's kind of, all of the elements that are on the web page are put on there inside these little tags, okay? The tag being kind of, you see like a less than sign, something like div, an ID, a class, and a greater than sign to kind of close the tag. So this is a tag, and this represents some kind of division, and that's what the div tag means. Here we have an image img tag. You can't read anything because it's tiny, but basically this means there's going to be a picture here, and then you have spans and A's for anchors and all of this stuff, okay? And this is how your web page gets rendered. Back in the day in the early 90s of the internet, the web pages were a lot simpler, and you could read through the HTML and really understand what the page would look like. Today, you look at the HTML of any web page, and unless it's like super simple, it's almost impossible to kind of decipher now. But that's how we go. And so this is what we want to do. Let's say we want to extract some piece of information. Remember earlier we've dragged this selector gadget link onto our bookmarks bar, and so now I have the selector gadget link. And so what I'm going to do is, while I'm on this Lego movie web page, I'm going to click selector gadget, okay? And when I do that, this little thing hovers in the bottom corner here, okay? Right now it says no valid path found, and then there's a few buttons, clear, toggle position, okay? And what I can do then is, as I hover over different elements on the web page, you see these big orange bars. And for some reason, Johnny Depp's right here. Go away, please. All right. I think Selector Gadget's kind of messing with the hover scripts here. So I'm going to just X out of Selector Gadget. Okay, let me just reload this page here. The drop-down menus have popped up. Okay, so I'm going to click Selector Gadget again. I'm going to hover over, and let's say I just want to extract this number 7.8, okay? This is the rating of the Lego movie. Should be a 10, but they gave it 7.8. And so when I click that, 7.8 shows up in green, and then a whole bunch of other stuff shows up in yellow, okay? And right now we can see that we are selecting anything with a span tag is what it's saying, okay? And I only want the 7.8. I don't want all of these other things, so I'm going to just click over this to say I don't want that either, okay? And then so when I do that, now we can see I'm only going to select things that have the span and dot rating value tag, okay? And it says there's 3 things on the screen with that tag, and I still only want one, so it's kind of in this sense, I'm trying to just get it down to 1, and I see, oh, here's one thing that is still yellow. It's a little bit like a seek and find game. And then I click that, and it says, okay, now we're going to just select strong span, and there's only one thing here. It says clear 1. And so this will be the tag that I use to select this value 7.8. This is the only thing on the entire web page that has strong span, and that is going to be this number 7.8. Okay, so now I'm satisfied. I'm going to just X out of here. Okay, I'm going to come back to R. Oops. And to read that in, first I'm going to use the command read HTML, provide it the website, and we're going to take the output of that and store it into Lego_movie. Okay, and when I do this, it goes to the internet. It downloads Lego_movie. Okay, and so I can ask, what is the class of Lego movie? And it says it's an XML document, okay? And we can ask type of Lego_movie, and it's really just a list. And we can ask kind of like, what's the structure of this list? And again, we see there's all sorts of stuff. All right, so to get all of the information out, though, what we're going to do is I'm going to say take Lego movie and put it into the function HTML nodes, okay? So if I do HTML_nodes, this will pull out everything from Lego_movie with the tag strong_span, okay? And so if I do this, this will extract out in the HTML. This is the piece of code that displays the 7.8, okay? And so in order to get just this 7.8, I'm going to say, I want you to pull out the HTML tags or HTML nodes that have strong span, okay? And then I don't want this entire tag. I just want the text that's contained within the 2 span tags. And so we're going to take this output and feed it into HTML_text, okay? And if I do that, and if I end there, then I would get the character string 7.8, okay? And if I want that as a number, then I just feed this 7.8 character string into the function as.numeric, and that will turn it into a number, okay? So by using the pipes, I don't have to keep track of everything, store everything on the way. I just say take Lego movie, pipe it into HTML node, pull out that node, pipe it into HTML text, just pull out the text, pipe it into numeric, and get the value as a number. Yes, question?
You didn't have to specify the output, just when you type it, assume that the output from the first function,
Yeah, you're just taking something and you're piping it into the next function, and the pipe just takes the output from the previous function or whatever it is that you're piping, and it just feeds it into the next function. So And so that works, and then we just take this result, 7.8, and we're going to store it into rating. So doing that, and then I get a rating of 7.8. Okay, and that's exactly what we want. All right. You can pull out other things. So here, that was an example where we just got one value. Let's say I want to pull the cast from the Lego movie. Okay. So I would use selector gadget. I come down here and I'm going to hover over the name. Okay. I'm going to say, all right, I want Will Arnett. All right. And this highlights a whole bunch of stuff. But we also, kind of scrolling through the page, and we see it highlights, plot keywords such as good cop, bad cop, evil businessman, and based on toy. And so, we just kind of want to scroll through and make sure nothing else is highlighted. And I don't know, are we able? And I just also I don't know if you noticed, but kind of the background was also highlighted, and I didn't want that. I just wanted the text here, so I just kind of clicked one of the things. And so in green, we have Will Arnett and Elizabeth Banks, Craig Berry, Allison Brie. We have all of these things, and so I have 15 values here, and this is how I'm going to select it. .item prop, .item prop. That is the thing. So I'm going to come here. I'm going to click Control-C on the keyboard to copy that. I will exit out of selector gadget. And apparently when I did it last time, the path was a little bit different, but it doesn't matter. I could use the same, do this here. So we're going to take Lego Movie. We're going to extract the nodes that have this. And so just so you can see kind of what this output looks like, it's a whole bunch of HTML tags. And then if we want to just pull out the text, we feed that into HTML text. Okay, and then we get a character vector of 15 values. And I'm going to store that as cast. Okay, so my cast, I have those 15 values there. Okay, we can pull out other things. So if we wanted, so earlier I just kind of hovered over, like if I wanted to get the this poster, okay, I can get the poster by doing HTML nodes. I'd use the selector gadget to figure this out. And in this case, the web address of the poster is stored under an HTML attribute known as src, kind of the source of this image tag. And so if I did that, for the poster, it gives me back kind of two URLs. And if I hover over one of them, and if I go to the this web address, this is where it is, right? And then if I wanted to, I could then throw this result into download and have the computer download the image located at this web address. Okay. You can also extract other things like larger things. So here is also on this web page, there are people's reviews. So here, this is, I promise I didn't write this, but 10 stars, a wonderful piece of art. This is my first review. I never wrote a review, but okay. Anyway, I have no idea who wrote that, but I probably would be friends with this person. And then, so we extract this, and so here is the content of that review. And you can talk about, read through this, and I don't know, if you wanted to do sentiment analysis, you'd say this is a positive review. Okay, so that's cool in of itself, right? Being able to go to a website and extract information from it. The real power of rvest, though, comes from the ability to create automated browsing sessions. Okay, so whenever you go on the internet and you open your browser, and I go to IMDb, I have done what I've created a session between my computer and the server, okay? And then when I click a link, I'm telling, my computer then tells the server, you know what? I want more information about Will Arnett. And I send a request to the server, and the server says, oh, you want Will Arnett's page? Okay, here is Will Arnett's page. and this gives you all of this stuff, and we find all of this, right? And then maybe I go, you know what? I click back, and I say, you know what? Go back to that page. I want the page on Elizabeth Banks, okay? And I tell the server, I request this thing, and the server sends this back, okay? We can do this inside R, okay? R can kind of open its own sessions, go to a web page, and then follow links to additional web pages, okay? So here I'm going to say, open a session starting at this page, which is the Lego movie page, okay? So now S, if I ask what is the class of S, S is a session, okay? Which is an interesting thing. And here I can tell R to then, starting in this current session, follow the link that says Will Arnett, okay? And if I did that, this will take me, if I just do that command, this navigates to Will Arnett's page, okay? And now I have updated my session to be at this page, and status 200 is kind of what we have. And then we could say, you know what? We want Will Arnett's page, and then download the HTML from Will Arnett's page, okay? And so if I do that, Will_page is now an XML document containing the contents of the page for Will Arnett, okay? So we browse to that page, and we've downloaded this, okay? And then now I can perform rvest tasks to extract information from Will's page, okay? So I kind of want to just show you that I can do this, and we'll just go through kind of the first 3 cast members here, doing an automated browsing session. So what I'm going to do is I'm going to create just an empty list for cast_movies, okay? And then what I'm going to do is, for each one, I'm going to start at the session S, and I'm going to follow the link that says that's I. So keep in mind, in cast is this vector that has the names Will Arnett, Elizabeth Banks, Craig Berry, so on and so forth. And so you can tell rvest to follow a link that has the words Will Arnett, okay? And so, if you have multiple links on the page that have the same name, then rvest just follows the first one, okay? So if there's like multiple links that say next, it's just going to follow the first one that says next. So the other argument is you can say follow the link and then just count out, like follow the 57th link on the page. We don't really want to do that, but but here in this case, there's only one link that says Will Arnett. So we're going to say follow the link that says Will Arnett. And then once you follow that link, read in the HTML, okay? And then from that page, what we want to do is, whoops, I don't want to go to the Windows Store. On each actor's page, what we're going to do is we're going to go down to their filmography and extract out the movies that they're in. So we're going to get what movie is Will Arnett in. So I'm going to select this. Teen Titans Go to the movies. Oh man, that's exciting. So I want this. I don't want this. I don't want this. And so we will get, Teen Titans Go to the movies, Show Dogs, Hot Date, BoJack Horseman, The Nut Job 2, and so on and so forth. And I think it says there's 236 things, and yeah, maybe there's 236 things that are going to get selected. That's fine. We will follow the path here is just BA, all right? And that's what we will extract. So I'm going to say the movies that we're going to store will go into cast $movies. We're going to pull out the nodes associated with BA, extract out the text, and then I'll just pull the first 10. Okay, and then we'll also get the years of those movies. So again, using selector gadget, I just kind of went here and I highlighted this and pulled out the selector gadget, and this was the path. We pulled out the text. I said I want the first 10, and then string extract here. This is just applying a regular expression to get something like the first 4 digits, because over here some of these things have a range 2014 to 2017, and I'm just telling it just pull out the first 4 digits. Don't get the whole thing. Okay, and then we will also just to keep track that this was Will Arnett's thing, I'm going to just store his name into cast movies $name. So this is where our list is going to have 3 things. Well, it's going to be we're going to create nested lists. So the first thing will be a list for Will Arnett with 3 things: movies, years, and name. The next will be a list for Elizabeth Banks with 3 things: movies, years, and names. And then finally Craig Berry, movies, years, and names. Okay, so it'll be 3 lists of 3. Okay, and this is automated. I just have it inside the for loop, and it's all powered by using the session that is still open and telling it to follow the link. So I will go ahead and do this, and it tells me, okay, it's going to Will Arnett's page, it's going to Elizabeth Banks' page, and then as long as our internet is working, it should go to Craig Berry's page and then finish here. Okay, and then so if I take a look at cast movies, indeed we've extracted the information from each of those pages, right? So it's a list of 3, where Will Arnett is a list of 3 consisting of movies, years, and names. Elizabeth Banks is a list of 3 consisting of movies, years, and names. And Craig Berry is a list of 3 consisting of movies, years, and names. Okay, and we can see it indeed has pulled Teen Titans Go, Show Dogs, so on and so forth. For Elizabeth Banks, we have the Happy Time Murders, Signal Hill, Pitch Perfect 3, Curb Your Enthusiasm. And then for Craig Berry, we have Toot and Puddle, the Lego Movie, and other stuff, okay? And it has kind of the dates and their names and all of that. And then just to kind of make the formatting a little bit nicer, I'm using the function from data.table for our bind list. This is not necessary, but we could do this. And here it kind of attaches everything here, and now we've extracted the information. Okay, and this was achieved solely entirely inside R. Once we've figured out which tags we want, we just tell R start a session, and now you can follow these links and pull out these pages rather than requiring us to visit the pages ourselves and providing R the address of every single web page there. And I think that's pretty cool. So so that's rvest, and we'll end here.